Hello, welcome back to LeetCode Daily Live, where I do the LeetCode Daily question, raw and cuts. So let's get started. So we have a medium today, something about subarray as well. So same theme as yesterday. So what do we have to do today? Let's see. So you're given an array, an integer array nums. The absolute sum of an array would be the absolute value of basically all the numbers summed. Return the maximum absolute sum of um, any subarray. So yeah, okay. The problem is pretty straightforward. We have to find a n or n log n solution. Also, yeah, Let's just look at an example. So, like, you basically want to find a subarray which is contiguous, and it should be either either the largest in the positive side or like as far as possible like on the negative side. So if this is only positive, well uh like you basically like just get all the yeah, I'm just thinking how to do this. Like, it's not too obvious on the like just seeing this, but I think maybe we can break down positive and negative. So yeah, so if this problem is find the biggest like positive array, and like you have negative numbers, well, you just want to like keep track of yeah, actually let's draw it out. So if we want the maximum for for only positive number, well, not only positive number. So like instead of doing the absolute value, like we we break absolute value down into finding the maximum and the minimum, and like the absolute value of those two, and then you get the maximum, and that should get you the answer, right? So how do we find the maximum value of an integer array though? Like the maximum subarray, I should say. So hmm yeah, so I think like first thing first, we can definitely um we can definitely combine these together, because like if you're using this, there's no reason to not use like the connected positive number together, right? Because well uh it makes your number bigger. So you always want to use that. So yeah, something like this, right? So yeah, so right now we have broken the problem down into finding the maximum subarray, and also finding and also like our array is going to have like one positive number, one negative, one positive, one negative. Um and actually if we have a negative number beforehand, well, we can just not look at it, right? Because like why would we include this? So like I don't know, if including the maximum, like if your current subarray includes the first uh negative number, you can always just cut that number to get a bigger um like maximum subarray, right? So we just skip that, and then like we look at the first, like we basically just go from the first positive number. um well, yeah, also one thing you mentioned, right? Like if we have negative number as well, we want to connect them as well, because like there are no reason to like just get one of those, right? Like if we want to get more positive numbers before after that, we have to go through like the whole negative number thing anyways. And yeah, I'll just give one case where this is like actually good. So for example, like this, well, choosing the whole array gives you 4, right? And that will be the maximum, but you do have to go through like a bunch of negative numbers. So we shouldn't just like check the maximum like contiguous well positive number. But one thing we can do is like we can check for each positive and negative pair. So um if this pair does give you a negative number, there's no reason for the next number to use this pair, right? Because it's like the same as -2, right? It's just like if you ignore that, it makes your subarray larger anyways. Um, but another case we have to consider is like what happens if we have like a bunch of um like a bunch of net positive pairs. So like if we have 3 minus 2, we do want to include that, right? So this will also be positive, and then, well, this would be like really negative. Actually, can we break the problem down even more? So like we will make 1 and 1 and like negative 84 here. So yeah, but again, what if what if this thing is like -1 and like you can connect more. So maybe like breaking it down again and again wouldn't actually be that. Oh, actually, if you keep breaking it down, it should be n log n. Well, because every time you look at a pair, um, you're basically making the array like half the length, right? So I think that'll work, but let's think about like can we do it in like one pass? Like is that possible? Um yeah, I'm just slightly worried about edge cases, like to be honest. So so if we have a current like running max, so we look at the first element, so it'll be 3, and then when we look at -2, it should go to 1. Uh, so it doesn't change. Like we also need like the current number as well, I think. So if we have let's see. Yeah, so the current like 3 1, and then we'll like that would be 6. So that's looking at 5, and looking at -4 goes back down to 2. And then okay, what else do we have there? Oh yeah, and then like we will look at 6. So that'll be 8. So we have a larger one. And then like obviously we have like -90 afterwards. So that would be like 82. Yeah. So yeah, so like this example, the array is like you have to use from the front. But like what happens if you have like something else? So something like this. Like would the algorithm still work? Yeah, so after you look at this is like obviously negative. Yeah, I think like first thing first, we want to find the maximum value like of the array, because like we can just choose that one element to be a subarray, right? And I'm pretty sure we can't use the absolute sum of any subarray of nums. Oh, okay. So if all the numbers are negative, well, you can have like 0, right? But yeah. So maybe initially we can set it as 0 actually, because like we are allowed an empty subarray of nums, and that would just be 0. Yeah, and then yeah, so like because like the running sum here is, well, is negative, right? So we just want to cut that out. But what if we reverse it actually? So we have like something like this maybe. So when we look at this, like the max, well, it should become 5, like because the current is like 5 and 1, 3 minus 1. So I think like whenever we reach -1, like whenever the current is like smaller than 0, we just don't want to use like the previous like current stuff that we have seen, right? Because like it's like the same thing as the -2 at the front, right? So you just want to like reset and like so it goes back to 0. But then like the running max we have considered like the largest like subarray like here already. Yeah, I think we just do that, and then we do the exact same thing for minimum. So like instead we want to find like the minimum. So it will be good if we have a function for that, and then we just get the number, like we just get the maximum and the minimum, and then we find which one has the larger absolute value. So yeah, unless I ran into some edge cases, otherwise this should work. Also, I don't even think we have to like I don't even think we have to connect the like the positive and negative numbers together. Yeah, like we just keep looking through using like this algorithm here. So let's get coding. So we have so what do we want? Yeah, so we want to deal with the max first. So max case, and then like we have the min case down there. So we have the best for max it will be 0. The best for min, that should also be 0. Yeah, also note that like all the numbers could all be 0, right? But like because we are looking at the absolute value, well, the absolute value, 0 should be the smallest. So yeah, and like if all the numbers are negative, like for max, that's still also fine. Like we just set it as 0 because like we don't actually have any subarray that's positive. So but like we'll be able to like solve it on min here. So yeah, so we have best max. We want a current, I think. So set it as 0. So for x in nums, so we want to loop through all the numbers. We want to do yeah, it's just x here. So we want to add that number, and now the like the running best, it should like we have to update that if cur is larger, and also if cur is smaller than 0, we should set cur back to 0. I think that's all we have to do, right? Yeah, I think so. Yeah, I think that's all we have to do. And then for minimum, it'd be something very similar. So again, we have cur to be 0. It's so similar, we can actually just copy the code up here. So best max, just turn this into min. So we want the min here, and instead of smaller, we want it to be larger. So like, when we are finding the minimum, let's say for, which way should we go for? Let's say for this one maybe. So like when we see a 5, because we want the smallest subarray, right? So obviously we want like if our current solution includes the 5, we want to cut that out, right? Like that will make our thing smaller because 5 is positive. And so we basically just do the same thing. Yeah, I don't think I need more explanation for this. So yeah, just keep going here. So current is 0. Yeah, current is equal to 0, and then we just want return the max of best max. So well, maximum is already positive, so we don't have to worry about the absolute value. But best min, we do have to do absolute value there. So hopefully that works. Okay, unless I run into some edge cases, I think this should work. Okay, nice. Yeah, so I think this question might it might be like I actually don't think this question is that easy. Like especially like it's very hard to prove that my solution works, like the cutting one, because like I guess you can say that like whenever I cut an array, like there is like where do I cut it actually? Yeah, I don't cut it here. Like whenever I cut an array, or like up here, whenever I cut an array, it means that like when when I'm saying cutting, I mean like setting current back to 0. It means the sum of like the previous, well, let's say there are like more cuts here, like the previous subarray here is negative, and like we won't have a case where like we cut after a positive number, right? Because like if the current sum is negative after adding 1, well, that means the previous number is even more negative, so the cut should be like there, right? But basically that means like we can't, like if we are using like something here, we can't add any part of this that actually makes the subarray more positive, and vice versa for the negative part. Yeah, like the actual code it's very clean, very simple, but yeah, it's definitely not the easiest to logic with. Yeah, well, thanks for watching, and I'll see you tomorrow. Bye.